Hi, this is Austin with Radical STEM Tutoring, and today we're going to see how long it takes for objects in freefall to hit the ground. Let's get started. Okay, first let's look at somebody dropping a baseball down to the bottom of a well, and we're going to find how long it takes to fall to the bottom. So let's go ahead and state what we can know about this problem. When he lets go of the ball, it's not going to have any velocity, so its initial velocity will equal 0. We can also go ahead and say that this is the point where our y-coordinate equals 0 as well, and that down here, the final y position, the bottom of the well, we will say that's equal to minus 20 meters. We'll have it negative since it's below the ground, and since it's in free fall, we know that the only acceleration it's experiencing is minus g, our gravity constant, or minus 9.8 meters per second squared. Okay, so to solve this, we're going to use a kinematic equation, the same one we used in yesterday's video, but instead of x's, we're going to use y's just because we're talking about the vertical dimension. So, we can see that our initial y position is 0, so this term will disappear from our equation. Similarly, our initial velocity is 0, so this whole term will disappear, which means that our final y position of negative 20 meters, we have that too, is going to be equal to 1/2 of our acceleration minus 9.8 times t squared, and that's obviously what we're going to be solving for. So let's go ahead and simplify this a little bit. Half of 9.8 is 4.9, so we can say that this is minus 4.9 t squared. Now, to get t by itself, we'll want to divide by this negative 4.9 on both sides. And that will give us that t squared equals 4.08. Now the last step to solve for t is to undo this square. Of course, we undo the square by taking the square root. So this tells us that t equals 2.02 seconds. Now, what if we want to take this one step further and also solve for the final velocity, how fast it's going right when it hits the bottom of the well, 2.02 seconds later? Well, we can use our other kinematic equation, which, if you remember, we get that by taking the time derivative of our position kinematic equation that we just used, and that gives us the velocity as a function of time. So here, our velocity as a function of time will be the derivative of taking the derivative of this, the derivative of a constant is just 0, so that disappears. The derivative of a constant times t is just the constant. These two constants, 1/2 a, stay here, while we take the derivative of t squared. Our power rule says we bring down the 2 and reduce its exponent by 1, and the 2 and the 1/2 will cancel out to give us that v final equals vi plus at. So now we can just plug in our numbers and calculate v final. So it's going to equal, remember our initial velocity is 0, so then we'll have a, which is minus 9.8 times the amount of time it took to fall down, 2.02 seconds, and that will come out to minus 19.8 meters per second. And remember, that's negative just because we've been calling the down direction negative ever since we decided acceleration was negative and we would have a negative position underground. So it makes perfect sense that we would have a negative velocity as well. Okay, next let's look at throwing a baseball into the air. If we throw this baseball upwards with an initial velocity of 10 meters per second, how long will it take to go up and come back down to its original height as it left our hand? Well, we know that the acceleration it's going to experience during this trip is minus g again. We can use the same kinematic equation, v final equals v initial plus at, to help us, but we'll only be able to use it for 1/2 of the trip. So if we look at when we're going up, we know that our initial velocity is 10, a is minus g, and at the very top we're going to stop moving in the y direction. There will reach a point where our vertical velocity is 0 before we start to fall back down. So our final velocity while we're going up is 0 meters per second, and that's what's going to allow us to solve for this. So we'll say that v final 0 is going to equal v initial of 10 minus 9.8 times the time it takes to go up. And now we can solve this for the time it takes to go up. So if we add 9.8 t to both sides, we'll end up with 9.8 t up equals 10. Then we can divide by 9.8 on both sides to get that the time it takes to go up equals 1.02 seconds. Now, we could solve the same type of equation for when we're going down. If we think about the time going down, then we'll start with a v initial equal to 0, and we'll have some final velocity, and we'll still have minus g as our acceleration. But there's a handy fact about this. Whenever this ball comes back down to its original height, it's going to reach the exact same velocity that it started with. So it'll have minus 10 meters per second of velocity once it comes back to this height. And in fact, if we worked out the equations using that, then we would find that the time it takes to go down is exactly the same as the time it takes to go up. So that tells us the total amount of time it takes to go up and back down is just 2 times the amount of time it took to go up. So our total time, if you will, is equal to 2 times the amount of time it took to go up. And of course that will be equal to 2.04 seconds. Alright, so that is how you calculate time and velocity for objects in Freefall. If you found this video helpful, please be sure to like it and share it, and have a radical day.